the 3 topics assigned to me, it's all about the non-parametric test. We're going to talk about the Spearman's correlation and the Kruskal-Wallis test. So let's just define first what is a non-parametric test. So many of the hypothesis tests requires normal distributed populations, or some tests require that population variances be equal. So what if for a given test such requirements cannot be met? So in these cases, statisticians have developed hypothesis tests that are distribution free. So such test is called the non-parametric test. Generally, a non-parametric test is easier to perform than the parametric test. It's usually less efficient than the barometric test, and it needs stronger evidence is required to reject the null hypothesis. So there are advantages and disadvantages in using the non-parametric test. So generally, the advantage is it is general and it is easy. But for the disadvantage, tests tend to waste information, sometimes falsely accepted, and tests are less sensitive than others. So let's just go on for the Spearman rank correlation. So those 3 are considered as non-parametric tests. Again, the first one is Spearman rank correlation. It is used to determine whether the correlation between 2 ordinal variables is significant. So we have here, please meet Mr. Charles Edward Spearman. In statistics, Spearman ranks correlation coefficient, or what we call the Spearman's rho, named after Charles Spearman, and often denoted by the Greek letter rho. It is considered again as non-parametric correlation. So Mr. Charles Edward Spearman was born in September 10, 1863 in London, United Kingdom, and died at the age of 82, September 17, 1945. So he is English, or he was an English psychologist known for work in statistics. As a pioneer of factor analysis and for Spearman's rank correlation coefficient. So Mr. Charles Edward Spearman introduced the rank correlation in the year 1904. Spearman rank correlation coefficient, measuring the strength of the relationship between 2 rank variables. Again, the variables being used here are rank, non-parametric, equivalent to Pearson correlation coefficient, calculated using the ranks of paired sample data entries, and it is denoted by R sub S. Okay, let's go back here. So the value that you're going to get in calculating the Spearman rank correlation coefficient, or the R sub S, must be between only to -1 and the +1. That means if you're gonna get 1.2 or greater than 1, that means your answer is wrong. It must be in between only to -1 and the +1. Let's have here the number line. The correlation coefficient ranges from -1. That means it is a perfect negative correlation. It is here. It is located here on the left side. And to 1, that means it is a perfect positive correlation. It is located on the right side. That means it is perfectly positive correlation. When are we going to use the Spearman's rank? Again, I have discussed that Spearman's rank correlation is equivalent to a parametric test, which is the Pearson correlation. We already know that we're going to use a Pearson correlation if the interval or duration level, you can satisfy this. It is linearly related and bivrate normally distributed. So we're going to use this if we're going to calculate it by Pearson correlation. That means if it doesn't fall on this category, what are we going to use? The Spearman rank correlation. Spearman correlation test measure the strength and the direction of a monotonic association between the two rank variables. Pearson correlation test measures the strength and the direction of a linear between two variables only. Here, the variables are rank, but here it's just variables. And this one, the associated being used for Spearman is monotonic, while in Pearson is linear. Example of ordinal data. So let's take the example of physical fitness level. So you can categorize it by having none, low, moderate, and high. So pain sensitivity level, it is none, low, moderate, and high. So you're not going to use Pearson correlation, but instead Spearman correlation. Let's talk about the monotonic function. By definition, monotonic function is one that either never decreases or never increases at it is independent variable increase. So let's just have an example here where in the first picture here, or the first diagram, is when the x variable increases, the y variable never decreases. That means if x is 5, then y can be 5 at the same time. Monotonically decreases. Let's say, for example, when x variable increases, but the y variable never increases. As you can see here, if x is x is 5, so ano siya, it never, variable x increases but the y never increases, hindi siya tumataas. So ibig sabihin parang kabaliktaran siya. But not monotonically, when the x variable increases and the y variable sometimes decreases and sometimes increases. So we have an assumptions in using the Spearman correlation test. We have, actually it's 5. So the first one is random sample. A monotonic association exists. Variables are the least ordinal. Data contains paired samples. Independence of observations. Data does not have to be sampled from a normal distribution. Let's talk about the first assumption, which is random sample. Here, as you can see, the sample that is used for your experiment should contain a truly random sample that is representative of one population of interest. Next is monotonic association exists. So it is always advisable to plot your data before deciding what test are you going to use. So the variable must exhibit a monotonic correlation between you run the Spearman correlation test. So you can visually see kung ano yung monotonic association that you're going to use. Next is, because if you got this, this is not monotonic, so you cannot be able to perform your Spearman correlation. And then for the variables are at least ordinal. So both variables should be measured on a continuous interval or ratio or ordinal. So we have, for example here, the interval measurement, ratio measurement, ordinal measurements, and nominal measurement. So in this case, we cannot use the nominal measurement because it is not being ranked. So those interval, ratio, and ordinal are being ranked. So that's why we can use the Spearman rank correlation. Next assumption is data contains paired samples. So in this case, as you can see, for the number 6, this student cannot be able to have a score in biology, and the ninth student cannot be able to have a score in chemistry. That's why those two students cannot be considered in performing your Spearman rank correlation, because we need to satisfy your fourth assumption, that your data must contain paired samples. You must have score here, and at the same time, you must have a score on the other side. Next is independence of observations. There should be no relationship between the subjects. Kaya kanina, this is merely related to your number 1, which is random sample. They mustn't be related. So, yung dalawang sample, if you have 2 persons, na i-consider, they must not be related to each other. Data does not have to be sampled from a normal distribution, just like this one. So you can use a Spearman correlation. Let's have the calculation. How are we going to calculate the Spearman rank correlation coefficient? So we have a formula here. The formula is R sub S is equals to 1 minus 6, the summation of D square, over N times N square minus 1. So technically, ito, it's difficult, a little bit difficult to understand compared to this one, because this is simpler than this one. So, how are we going to get, or paano natin nakuha yung N cube minus N? Diba sa math, sa basic math, we're just going to multiply your monomial to your binomial. So in this case, we use the distribution property. So N times N square is N cube. And then your N, multiply it to 1. Then you got N. Why do I encourage you to use N cube minus N? Because later, if we're going to calculate it using the Excel, or even in your paper, it is easier to understand or easier to do if it's like this na. So we have where N is the number of paired data entries, and D is the difference between the ranks of the paired data entries. So you're just going to get or to know the value of N and the value of D. So first, the null and the alternative hypothesis for this test are as follows. For the null hypothesis, R sub S is equals to 0. That means there is no correlation between the variables. For the alternative hypothesis, R sub S is not equal to 0. That means there is a significant correlation between the variables. It can be positively correlated or it can be negatively correlated. We have different steps to follow. We need to follow in performing the testing or the test, the Spearman rank correlation coefficient. The first one, again, we need to state your null and alternative hypothesis. So the second one is we need to specify the level of significance. Sometimes it is given to the problem. Let's say, for example, it is 1% level of significance. Or if it's not given, we usually use 5% level of significance. Third, we need to determine the critical value. So in this case, we're just going to look at the table. We have specific or Spearman's R table for this. So we're just going to look at the critical value. So find the test statistics on your fourth step. This is where we're going to perform the calculation. So we're going to use the formula for this one. The fifth step, so we need to make a decision to reject or fail to reject the null hypothesis. So we need to consider this part. Null hypothesis, that means no association in the population. And then we have what we call the right-tailed, the left-tailed, and the two-tailed. Because this is very important. We need to know if it's right-tailed or left-tailed or even two-tailed. Because as you can see on the Spearman's rank table, two-tailed is given a different value compared to one-tailed. That's why you need to know, you need to really know if it's two or one-tailed. If it's one-tailed, you need to know if it's right or left. So in this case, this is your decision rule. So the test against alternative of positive association, the decision rule is you need to reject your null hypothesis if your computed R sub S is greater than to your critical value. You need to reject if you're using the left tailed if your R sub S is less than to your negative critical value. And if it's two-tailed, it's just the same. So you're going to reject if it's less than, or you're going to reject if it's greater than to your critical value. And then you need to interpret the decision in the context of your original claim. So before performing the computation, let's just first understand or recap. Let's just have a recap for us to be able to know if it's two-tailed or one-tailed. Again, this is very important. So let's just have an example here. Example. The first one, are engineers less extrovert compared to statisticians? So this, in this case, the word being used is less. So if you use the word less, you are considering a one-tailed test. So is there a difference in the memory retention for individual at the age of 20 compared to their memory at 60? So the word being used here is difference. So the researcher or the author being is not typically sure if it's more than or less than. That's why the word given here is difference. So we're going to consider the two side. Is it left or is it right? That's why we're going to consider the two-tailed test. The third example is there a difference in college GPAs for students who were homeschooled than for students who went to school, to public school? So the word again is difference. Again, it is two-tailed. Next is, do people who take a daily vitamins live longer than people who don't? In this case, the word being used is longer. So that's why it is considered that you are pertaining to only one side. So you're going to consider a one-tailed test. So at the table, of course, you're going to look at the side of a one-tailed test. Next, the fifth example is, are extroverts less stressed than introverts? So again, the word being used is less, so you're going to use one-tailed test. Last example is, does yearly income for nurses differ from the yearly income of traffic controllers? The word being used is differ. That means they don't really know if it's higher or less. That's why you're going to use for a two-tailed test. You usually encounter those words. You just need to be aware when are you going to use it. Next is, let's just have an example. Okay, let me, okay, because I need this one, the Excel. All right. So we have here the first example of a Spearman rank correlation, wherein I considered it as two-tailed test because it used the word difference. Is there any difference in rank 1 compared to rank 2? So we're talking about food. So we have here types of food. It's food A, B, C, D, E, F, G. So for the rank 1, we have here the data, which is 2, 1, 4, 3, 5, 7, and 6. For the rank 2, we have the data 1, 2, 2, 2, 5, 6, 7. So in this case, I already put one or two columns on the side. D is, that means the difference. So you're just going to subtract your rank 1 to your rank 2. So in this case, we're going to get this for the D. That means 2 minus 1 is 1. 1 minus 2 is negative 1. 4 minus 2 is 2. 3 minus 2 is 1. 5 minus 5 is 0. 7 minus 6 is 1. 6 minus 7 is negative 1. Actually, the negative sign here doesn't really matter because we're going to square your D. If you're going to square your D, 1 square is 1. Negative 1 square is negative, negative 1 square is 1. 2 square is 4, and so on. So until here, negative 1 square is, again, 1. You're just going to follow the formula D square. So by getting that D square, that means you're going to have the summation of the D square. So in that case, you're going to add from the top up to here. So 1 plus 1 plus 4 plus 1 plus 0 plus 1 plus 1. Then you've got 9. So we already know that N is how many? 1, 2, 3, 4, 5, 6, 7. So the N is 7. The summation of D square is 9. Then we can be able to substitute those value to your formula. Let's just have it. Substituting your values to your formula. Again, 1 minus 6 is already given. It's default. And then, again, summation of D square is 9. So that's why we have 9 here. So N is equals to 7. So that's why we have 7 here. Times 7 square minus 1. Performing 6 times 9 is 54. And then performing first what's inside your parentheses. So in PEMDAS, you're going to do or perform first the parentheses. So 7, what's inside the parentheses is 7 square minus 1. Again, 7 square is 49. And then minus 1, that's why you have 48 here. And the next is 1 minus 54 over 336. We've got the 336 from multiplying your 7 times 48. And then performing 54 over 36, then you can, you've got 0.161. And then we're going to subtract your 1 minus 0.161. Then you can have 0.839. So it actually it's just the same here on the other side. Um, the difference is I use the Excel in calculating this part. So let's say, for example, in this case, because in Excel, we don't usually count it just like 1, 2, 3, 4, 5, 6, 7, because Excel do have a formula for that. So that is count, and then you highlight the um, the cells that's included to your formula. Let's say, for example, A1 to A8. Mm, let's do it again. So here is count, and then highlight, and then you've got 7. So from here, 1, 2, 3, 4, 5, 6, 7. All right. So in this test statistics, it's just a summary of this formula. Why do I put this formula instead of that? Because in performing this, it's easier for us to use the n cube minus n. Let's just try to do it here at the bottom. Okay, equal sign. So we have the default, which is 1, right? So subtract. I usually group it according to this. So I group it as 1. So I'm going to do first the 6 times the value of 9, because this is the value of the summation of this square. And then close it with parentheses because I group it as 1 here on the top. And then you need to divide it, the one at the bottom, which is um, which is n cube. This is your 7 cube. In mathematics, we usually use that symbol as a cube. And then multi or subtract it with, again, your n, this one. And then close the parentheses. How many parentheses do I've got? I have the first open and close parentheses. I have the second open and close parentheses. And I miss one thing because I have one open parenthesis here. So I need to close it at the same time. So when you open, you need to close. And then enter. So when you hit enter, then you can get your correct answer. This one is just the same as this one. So let's color it and make it like that. Okay, this is the same. So this is by calculating by paper and pen. This one is by calculating by your Excel. Okay, let's just have the interpretation. Getting the critical value, let's just go back. We considered a two-tailed test, right? So for the two-tailed test, this is what I'm saying. The two-tailed test has different table as for the one-tailed test. That's why you need to be aware of your kind of test. Here we have the n, which is 7, and we usually use 5% level of significance if it's not stated on your problem. That's why we consider this part. So level of significance is 0.05, and then the number of sample is 7. That's why your critical value is 0.786. Okay, take note of that. So we're going to use it here, 0.786. So we've got the test statistics value, which is 0.839. It is greater than your critical value, which is 0.786. So that in that case, from your decision rule, we need to reject your null hypothesis because as you can see on your diagram, your critical value sits here. This is your, let's just suppose this is 0.786. But then the computed test statistics lies here, a little bit farther from zero. So that's why, as you can see, this is a rejection region. The red one is the rejection region. That's why we need to reject your null hypothesis. So, can we have the second sample? Hello po.
Sir, the
Ay, thank you po. Okay, can we have
hello
the
po.
let's just
Hello.
proceed to the second example, which is X variable greater effective than Y variable? In this case, we use the word greater. That means it is right-tailed. Again, on your, let's just have this one. On your diagram, this part is right-tailed, right? And this one is left-tailed. Okay, so we considered the right-tailed because we use the word greater. Okay, we have the sequence 1 to 7 again. I think 7 is my favorite number. So let's just rank your first or your X. So we need to find your X's. Let's rank it. So the first highest number is 99.2, followed by 98.8, and then, and so on. So the least number is 96.7. That's why it is your last rank, which is your seventh rank. Let's just consider the next column, which is your Y. Of course, if you have X, then you can have Y. Let's rank your Y. Your Y, your highest Y is 87.2. That is your highest rank, which is 1. And then and so on. And then your lowest rank is 7th rank because it is the least value of Y, which is 73.2. You just need to follow you can get the D by subtracting your rank 1 to your rank 2. We can have 5 minus 7, then you can get 2. 1 minus 2, you can get 1, and so on. 2 minus 4 is negative 2. 4 minus 6 is negative 2. 3 minus 5 is the same, negative 2. And 7 minus 1 is 6. 6 minus 3, then you can get 3. Okay, by having the square root of D, then you can get D squared. Again, negative 2 square is 4. Negative 1 square is 1, and so on. 6 square is 36. And then 3 square is 9. And then you need to add those numbers, 4 plus 1 plus 4 plus 4 plus 4 plus 36 plus 9, for you to be able to get the summation of these square. So what is the answer? It is 62. Again, from your example, we already have the value of summation of this square, and we have the value of n, which is 7, right? We have the number of samples. We have 7 samples. Okay, by substituting the summation of this square and your n, let's just plot it in the formula. Then we can have 62. So 6 times 62, again, n is 7. That's why we have here 7 times 7 square minus 1. Calculating that, 6 times 62, then you can have 372. And then 7 times 48, then you can have 336. Dividing those numbers, 372 divide 336, then you can get 1.1071. So in this case, your test statistics, computed test statistics is negative 0.1071. So using the same as an Excel here, you can rank the values according to the highest to your list value for your x and y. And then by computing d square, I usually use the formula here by using, again, when you're going to start formula in the Excel, you need to start it with the equal sign, and then just click the cell that you're going to multiply. So I need -2, so I click here. Multiply it again to your the same number, because you're going to get the square. So F2 times F2, I'm pertaining to -2 times -2. Hit enter, then you can get 4, and so on. So in your summation of d square, so you just need to hit this one, summation, and it's automatically highlight the numbers from this one up to your top number. And then you just need to hit enter. So you don't need to compute so much for this. And then we've got already your critical value for your one-tailed test, which is 0.714. This is according to the one-tailed test 5% level of significance, and to the number of sample, which is 7. That's why we've got 0.714. We're going to take note of that. And then your test statistics is negative 0.1071. Let's just have the interpretation. So for the decision, it is negative 0.1071 is less than your critical value got from your table, which is 0.714. So as you can see on the diagram, we have here your critical value is 0.714. So it lies here in this part. So that means the rejection region is the red color. But if we're going to plot your test statistics, it can be here on this part. So it is not lying on the red color. That means you need to accept that means your null hypothesis has been accepted. That's for the right tail. And then last example for Spearman's Spearman rank correlation. Let's just have left-tailed for this. So again, we have the sequence 1 to 8. You have the x and the y. So is y variable less than x variable? So we have the less word, the word less has being used. So that means we are pertaining to a left-tailed. So we need to rank your x. So how we're going to rank the x? Okay, I'll just cover it. So in this case, we have the data under x and y. Okay, for this one, the first highest number is 30, right? But the problem is we've got two 30s. So in this case, the first and the second rank ay nakay 30. So what are you going to do is just to add the rank, the rank cues. First plus second, you've got 3, and then you get the average. You need to divide it by 2. That's why the rank of 30 is 1.5. And then just follow the next number, which is 28. It could be 3 because you already used, again, the 1 and 2, right? First and second rank has been used. So the next rank is third, followed by fourth, and then the fifth. So in this case, for the fifth, it is 23. 23 ay dalawa. So what are you going to do is just to add the fifth rank plus the sixth rank. You've got 11. You need to find the average by dividing it by 2. That's why you've got 5.5 at the same time for 23. And then next is the 6 have been used already, so you need to follow the next rank, which is 7. So 22 needs to take the 7th rank, and then the last or the least number of x will be the 8th rank. You're going to do the same for y. So in this case, the first is 32 and then followed by 2, 3, 4, 5, 6. But the least number is 24, which is happened to be 2, which is happened, we've got two 24s. So the numbers sharing for that rank is 7 and 8, right? So 7 and 8. So you need to get the average. You need to divide it by 2. That's why the rank used for 24 is 7.5. That's why we have here. I just put a little bit of color for that. So you will be able to recognize that those things are the same. It's just the same. You just need to, I just need to color this one. And it's just the same. Just follow the D. Same procedure. You just need to subtract the rank 1 to rank 2 for you to be able to get the D, the value of D. So 8 minus 3 is 5. 7 minus 7.5 is negative 0.5, and so on. Until here, 4 minus 2 is 2. The same procedure, you need to get the square of your D. So 5 square is 25. Negative 0.5 is 0.25. You're just going to square your D, just like this one. I'll just need to delete it first. Again, equal sign. I need to multiply my 5 to, because it's square, so I need to multiply it 5 times 5. That's why I need to have 25. And then again, select the cell. You multiply it with the same cell, and so on. But in this case, I won't be able to, or I will not do it one by one, because if I've got 100 of data here, it's very difficult to do it one by one. That's why I'm going to highlight it. And as you can see, I've got a solid square at the right bottom part. So when you drag your cursor there, it will become the plus sign. So you just need to drag it down. So that means the formula you've created on this part has been copied on the succeeding cells. So it's easier for you to create your formulas. And then again, you're going to have the summation of this. You just need to hit this icon. That means it's a summation. It's automatic. And then you hit enter. So let's just do it here. Okay, we've got the same answer, 88.5, and in this part, it's 88.5. So even if you are performing paper and pen, or even doing it in the Excel, it must be the same. Okay, this one is a little bit complicated formula, because as you can see, this example, we have 3 the same number. So 30 is the same, 23 is the same, and 24 is the same. So we've got 3 the same numbers. So that's why the M pertains to the number that is the same. So how many M I'm going to use here? 1, that's for a first group, 2, and 3. So what I'm pertaining to that is, I need to put a color. So the color of the first one is purple. So let's just take it purple here. Okay, so that means this part is pertaining to that. Next is green. So that means this part is pertaining to your 23, which is 5.5 rank. Yun yung rank niya. And then this group is pertaining to the orange one. So this is pertaining to the 24. in this part. So that is 7.5. We already have the values for each of the number because we already got the summation of d square, which is 88.5. And then what else do we have? We have the value of n here, which is 8, because we have, if you're going to count the sequence, it is 8. And then we have 2 here. Why do we put 2 here? Because remember, the color, the purple color pertains to 30. How many 30 do we have? We've got 2. So that means your m that you're going to put here is 2. Just happened that you're 30. Let's just say, this is not included to the problem, but let us say your 30 is 3. Let's just say that your 30 is 3. So what are you going to do is just to make it 3, not 2 anymore. Why? Because we've got 3 30s. Okay, let's just go back to the original problem. I used 2 because we only have 2 30s. Okay, just following the formula. The green one pertains to 23. How many 23s do we have? We've got 2 23s. That's why the 2 is written here at the same time. And then the orange color is how many 24 do we have? We've got 2 24s. So we've got 2 here. Let's just substitute it in the formula. Okay, let me color it first. All right, so let's just substitute in the formula. 2 cube, 6 times 88.5 is, we just need to rewrite it because we need to extract first what's inside the parentheses. Remember the PEMDAS, we need to do the parentheses first. What's inside the parentheses first? So 2 cube is 8. And then you need to subtract it by 2. That's why you've got 6. It is the same as this one. 2 cube is 8 minus 2 is 6. 2 cube is 8 minus 2 is 6. So that's why you have 666 here. We have 6, and we have 6. And then let's just extract what's inside the parentheses again at the bottom part. 8 squared is 64. You need to less 1. That's why you've got 63. And then let's just proceed with the formula. Rewrite again. 1 minus 6 times 88.5. So in this case, why do we have 1 half? Remember, we have 112. Let's just have here in the Excel. We have 112. And then you multiply it by the whole number, which is 6. Remember on math, the whole number 6, it always happen to have 1 at the bottom. That's why if you're going to multiply that number, you've got 6/12. Or if you're going to simplify it, then you've got 1 half. So that pertains to this part. So 1/12 times 6 is 1 half. That's why I've got 3 1/2 here. And then performing 8 times 63, then you've got 504. All right. So to make it easier for us to do the formula, let's just extract the 1/2 first, the 3 1/2 first. 1/2 plus 1/2 plus 1/2, then you can have 1.5. Your 1.5, you need to add it to your 88.5. That's why you've got 90. Ganun lang po siya. You've got 90, and then you multiply it by 6. And then, just rewrite your 504 at the bottom. Okay, on the side. So, 6 times 90 is 540 over 504. Let's do the division first because it's in PEMDAS, the D comes first before S. So 540 over 504, then you can get 1.0714 By subtracting 1 minus 1.0714, then the final answer would be this, 0.0714. And then let's take your critical value from the table. That's why we can get, it's here. One-tailed test, remember, it's left-tailed because we use the word less. So in a one-tailed test, it is 0.05 level of significance times 8. Your n is 8. You've got 0.64, 3. And then the computed test statistics is 0.0714. So if you're going to have it like this, you need to accept your null hypothesis because your computed test statistics is greater than to your critical value. So we can have the interpretation at the 5% level of significance, there is enough evidence to conclude that the null hypothesis has been accepted. So I'm not going to discuss another two-tailed test, but I already included into the PowerPoint, so you can be able to practice. So let's just proceed to our Kruskal-Wallis test. For the Kruskal-Wallis test, so Kruskal-Wallis test is used to determine whether 3 or more samples were selected from populations having the same distribution. So we have here omnibus test uses many groups of data to be analyzed, usually 3 or more. So if you're going to test 3 or more groups, then you will use the Kruskal-Wallis test. A statistical analysis to find the significant difference between several sets of data that came from independent samples. The data are not normally distributed. That's why it is considered also as non-parametric because the data being used is not normally distributed. So the non-parametric counterpart of one-way ANOVA, it uses data in ordinal scale. Remember, the Pearsons are the counterpart to non-parametric is Spearman's rank. But in this case, your one-way ANOVA, the counterpart in a non-parametric test is your Kruskal-Wallis test. Okay, for Kruskal-Wallis test, the null hypothesis, there is no significance in the distribution of the populations. And for the alternative hypothesis, there is a difference in the distribution of the population. So the two conditions for using the Kruskal-Wallis test are, the first one, each sample must be randomly selected, and the size of each sample must be at least 5. If these conditions are met, the test is approximated by a chi-square distribution with k minus 1 degrees of freedom, where k is the number of samples. So let's just see the formula here. So given the 3 or more independent samples, the test statistic H for Kruskal-Wallis test is this one, 12 over n times n plus 1. Multiply it with r sub 1 square over n sub 1, r sub 2 square over n sub 2, and so on. So this pertains to the number of groups that you're going to have. That's why it is k. So it pertains to the number of samples. If you have 4 groups, then you can have 4 R's here. So you can have R1, R2, R3, and R4. If you only have 3 groups, then what you can have here is only R1, R2, and R3. So K pertains to the number of groups that you're going to have. So K represents the number of samples, and N1 is the size of the nth sample, N is the number of the sample sizes, and N is the number of ranks of the nth sample. So I pertains to the number of the samples that's given to your problem. So let's just have the steps in performing the Kruskal-Wallis test. So the first one is you need to identify the claim. So you need to state if it's null or alternative. The second step is you need to specify the level of significance. Then you can have the alpha. It is usually given to the problem, but if it's not, again, you're going to use the 5% level of significance. Third is you need to identify the degrees of freedom, wherein you can get the degrees of freedom by subtracting 1 from your K. Next is to determine the critical value and the rejection region. So in this case, you need to use or to look at the table of the chi-square distribution. The next one is you need to find the sum of the ranks for each sample. So list the combined data in ascending order and rank the combined data. And the sixth step is you need to calculate the test statistics using this formula. Next step is make a decision to reject or fail to reject the null hypothesis, wherein decision rule here is we can be able to reject the null hypothesis if your H test statistics is greater than their critical value. Otherwise, you need to accept your null hypothesis. And then from that decision rule, then you can be able to interpret the decision in the context of the original claim. So let's just have first your first sample. Here, it is stated that you want to compare the number of crimes reported in 3 police precincts in ACT. To do so, you randomly select 10 weeks for each precinct and record the number of crimes reported. The results are shown in the table in the next slide. So we can have here at 0.01 alpha, you can conclude that the distribution of crimes reported in the three police precincts are different. So let's just have here the table. It indicates the satisfaction ratings in assistance during COVID-19 lockdown. So 3 groups of participants rate their satisfaction in assistance during the lockdown. So the rating scale is from 1 to 10. So 1 is the lowest and 10 is the highest. As you can see, we have 3 groups. So we have the low, the middle, and the upper. So each group pertains 5 sample data. The first thing to do is just to, let's just put it here on the side. So remember, this is the group, the low, the middle, and the upper. So what I did here is just to put this in the table, the same table. That's why I have, how many 1 do I have? 1, 2, I've got 3 threes, this one and this one. And then I've got 4, I've got 2 4s, this and this. I've got 2, 5, I've got here and here. And then how many 6 do we have? I have 1 6 here, so it is this one. And then how many 7 do I have? I have 3 7. So it indicates this, this, and this, and so on. I've got 8, 9, and 10. So by putting that in a table, then I can be able to clearly rank it one by one. So what I usually do is just to rank it by number. Um, okay, and then I need to color it like that. So I've got the first rank 1, 2, and then I've got 15 data, right? That's why I have 15 ranks here. But remember, this is the same. This is the same at the same time. And then 5 is the same. And then 7, we've got the 7. They are all the same. And what else? Nothing more. Okay. So in this case, we need to calculate. I just considered it as new rank because those data are sharing to one rank only. So what is the rank, which is the third rank plus the fourth rank? You need to get the average. So you need to divide it by 2. That's why you've got 3.5. That means 3 is sharing the rank 3.5. Okay, and then followed by your 4. You've got 2 4s. The rank is 5th plus 6th rank. Get the average. So you need to divide it by 2. You've got 5.5. Next is how many 5 do we have? We've got 2 5, right? The rank being shared here is 7, 7th rank and 8th rank. We need to divide it by 2. That's why it is 7.5. This is the same because wala siyang kaparehas. Nothing the same. So we have, how many 7 do we have? 3. So the ranks are 10 plus 11 plus 12. You need to divide it by 3 because you're going to get the average. So that's why they are sharing for the 11th rank. And then just follow 13, 14, 15. That means this is new rank. This is the table that we're going to use now. This is the rank that we're going to use. And then we're going to plot it to your table. Okay, how are we going to do that? Here, 6. Your 6th number is your 9. 9th rank. So we're going to put 9. Let's make it a little bit bigger. Okay. And your 8, your number 8 is 13. Your 13th rank. Followed by 7. Your 7 is 11, right? Another 11 here. And 5, your 5 is 7.5. I'm just going to do it one by one so we can follow. Your number 4, this is number 4, right? What rank is it? 5.5. Okay, how many 4 do we have? 2. I need to look at here. I need to put 5.5. And then 1 is 1. And then 3 is 3.5. And also this. 9. Let's find number 9. The number 9 rank is 14th. Let's just put it 14th. And then your 10, your number 10 rank is 15th. So let's just put 15th. Your 5 is 7.5. So let's just put 7.5. And then your 2 is this one. Let's just put a little bit color of this so it's because we are confused already. So the colored one, the colored column is rank. So we're gonna call it rank 1. On the other side, we're gonna call it rank 2. And then rank 3. Again, we have 3 ranks because we have 3 groups. Okay, so we're going to use it by, we need to find the summation of each rank. So again, hitting that summation symbol, this is your answer. Okay, so when you're going to add 11 plus 9 plus 13 plus 11 plus 7, then you can have 51. It's just the same as this because your low rank is getting from this table, right? And then you can be able to have 51.5, 35, and 33.5. Those are the rank summation. So take note of that. So we have the null hypothesis, which means that there is no difference in the distribution of the population. So that means all three groups are equal. So that is our null hypothesis. For the alternative, there is a difference in the distribution of the populations. So again, DF from our step, it is stated that we can get your degrees of freedom by subtracting your K minus 1. So the K pertains to the number of group that we have, which is 3. We have 3 groups, the low, the middle, and the upper. So 3 minus 1 is 2. So that means your degrees of freedom is 2. And then it is stated in the problem that your level of significance is 5%. That's why we use 0.0.5. So looking at the table of chi-square, which has which is used for your Kruskal-Wallis, your level of significance is 0.05. This is the column for that. And then your DF or degrees of freedom is 2. This is the row. Intersecting it, then you can find your critical value. Your critical value now is 5.991. Okay. Calculating your H statistics. Let's just calculate. We take note first your critical value. So take note of 5.991. So calculating your H statistics, plotting it into your formula, 12 over n times n plus 1. Your n pertains to the number of samples of the 3 groups. So you've got 15. So because we have 5 samples for the low, 5 samples for the middle, and 5 samples for the upper, then you can have 15. So substitute the 15 for the n. 15 times 15 plus 1. And then we've got the value of r sub r sub 1 square. So your r sub 1, the summation of it is 51.5, right? We got it from here. This one. Make it a little bit bigger. Okay, 51.5 over 5. So where did I get the 5? It is a number of data samples for each group. So this is your rank. So how many samples do we have for this group? We have 5. So that's why I'm gonna put 5 here. Plus 35 square over 5. At the same time, the middle is, we've got 5 samples. And then 33.5, we've got the third rank pertaining to 5 sample data for that group. And then the total number of samples is 15 plus 1. Okay, let's just have, when you're going to calculate it, then you can be able to get 1.35. So I'm going to use this part for the calculation. So let's just take, if you're going to look at the formula itself, this part, it's very difficult to be able to get the result if you're just going to look at it just like that. So what I'm going to do here is just to group it. Okay, I'm gonna group it. The first one is I'm gonna group what's inside the parentheses. So here. So this is my first group. On my first group, I'm gonna group it into 3. This is my group na gagawin. What I'm going to do is just to calculate this first, equal sign. Okay, 51.5 is square. I'm gonna square it, right? And then divide it by how many? By 5. Okay, so as you can see in the formula, I multiplied 51.5 times 51.5, then I divide it by 5. That is my first group. I'm gonna name it R1. All right, I'm gonna name it R1. Next, R2. we need to find R2. So R2, I'm going to pertain it to this part. This is my R2. Okay. So in this case, I'm going to use again the Excel, but you can use also the calculator. But for me, it's easier for me to use the Excel. Okay, 35. Because it's square, you need to multiply it to the same number, which is 35. So you need to select the cell. This is a cell. Okay, and then divide it by what number? 5. Coming from the formula. Then I've got the R2. Okay, the last rank, which I'm gonna name it R3. This one. Okay, so equal sign, multiply it by 33.5. Because it's a square, you need to multiply it to the same number, 33.5. So I'm gonna choose this cell twice. Divide it by 5. Okay, so in this case, I already got the answer from this. By, remember, I've got the answer for this, which is 534.45. I've got the answer for this, which is 245. I've got the answer for this, which is 224.45. So you need to add the 3. So I need to add the 3. My answer is 999.9. When you add together, it's 999.9. Okay, this I've done with this side. So what I'm going to do is this side. Okay, so I'm gonna calculate 12 over 15 times 15 plus 1. Okay, so it is, I have 12. Okay, and then let's just do the bottom part first. 15 times 15 plus 1. You have 240. And then for the 12, you have 12 divide. What is the answer for 15 times 15 plus 1? It's 240, right? So I'm gonna get the answer for this part by dividing this 12 over 240. So that is 0.5. That means this box is 0.05. Okay, take note of this. I'm going to color it first. And then, which is the last group? The last group is this part. So this one is a little bit easy because you're just going to multiply your 3 times. So obviously 15 plus 1 is 16. So you just type it like that. So you've got 48. Okay, so you've got the answer for this group, and this group. Then you can go to your formula. H is equals to, okay, equal sign. Remember, when you're going to do formula in an Excel, you must start with the equal sign. Again, what is the value of this part? It is 0.05. So click 0.05 and then multiply it by multiply it by the answer for this one, which is 999.9. Okay, and then subtract it because you have minus sign here. You need to minus it by 48. And then your answer is 1.95. So that's your answer. So the H statistics calculated here is 1.995, which is less than your critical value got from your table. So that means your null hypothesis has been accepted. There is no significant difference on the satisfaction ratings of low, middle, and upper class.